Question 1. A national environmental agency has recently enacted new regulations mandating the phased reduction of specific industrial greenhouse gas emissions, requiring detailed annual reporting on energy consumption patterns and associated emissions intensity for all facilities exceeding a certain production threshold. The manufacturing plant, already certified to ISO 50001-2011 and transitioning to ISO 50001-2018, must now integrate these new reporting obligations into its energy management system. Which of the following actions is the most critical and direct step to ensure the NMS effectively addresses these updated legal requirements? Option A. Update the energy policy to reflect a commitment to reducing greenhouse gas emissions, without specifying the new regulatory drivers or reporting mechanisms. Option B. Revise the organization's legal and other requirements register to include the new emissions reporting mandates and assess their specific implications for energy performance indicators and operational controls. Option C. Conduct a comprehensive review of all energy-consuming equipment to identify potential upgrades that could indirectly contribute to emission reductions, irrespective of the new reporting requirements. Option D. Initiate a company-wide awareness campaign about climate change and its impact on industrial operations, without initially linking it to specific regulatory obligations. Correct answer is B. Revise the organization's legal and other requirements register to include the new emissions reporting mandates and assess their specific implications for energy performance indicators and operational controls. Explanation: the transition to ISO 50001-2018 necessitates a thorough review and update of the Energy Management System, NMS, to incorporate any changes in legal and other requirements related to energy. Clause 6. 1. 3 of ISO 50001-2018, legal and other requirements, mandates that the organization shall determine and have access to the legal and other requirements that are applicable to its energy use, consumption, and efficiency. When new legislation or amendments to existing laws are enacted, such as a revised national emissions trading scheme or updated building energy performance standards, the organization must identify their impact on the NMS. This involves assessing how these new requirements affect energy performance indicators, operational controls, energy objectives, and the overall strategic direction of the NMS. The process should involve reviewing the existing legal register, determining the applicability of the new regulations, and then updating the NMS documentation, procedures, and training to ensure compliance and integration into the energy management processes. For instance, if a new mandate requires reporting of Scope 1 and Scope 2 greenhouse gas emissions with specific methodologies, the NMS must be updated to capture, calculate, and report this data accurately, potentially requiring modifications to data collection systems and the establishment of new performance indicators. The core principle is proactive integration of evolving regulatory landscapes into the NMS framework to maintain its effectiveness and ensure continuous improvement. Question 2. When conducting a gap analysis for an organization transitioning from ISO 50001-2011 to ISO 50001-2018, which of the following represents the most significant conceptual shift in the management system's approach to energy performance improvement? Option A. The increased emphasis on establishing specific energy performance indicators, NPI, without a corresponding need to link them to strategic objectives. Option B. The introduction of a mandatory energy management policy, which was not a requirement in the 2011 version. Option C. The specific clause detailing the requirements for internal audits, which saw a complete overhaul from the 2011 standard. Option D. The enhanced integration of energy management principles into the organization's strategic planning, and the explicit requirement to understand the organizational context and interested parties' energy-related needs. Correct answer is D. The enhanced integration of energy management principles into the organization's strategic planning and the explicit requirement to understand the organizational context and interested parties' energy-related needs. Explanation: the transition from ISO 50001-2011 to ISO 50001-2018 introduced significant changes, particularly concerning the integration with other management system standards and the enhanced focus on strategic energy management. A key area of divergence is the emphasis on the Plan Do Check Act, PDCA cycle within the high-level structure, HLS, of Annex SL, which is a foundational element of ISO 50001-2018. While ISO 50001-2011 also utilized PDCA, the 2018 version embeds it more explicitly within the overarching framework of the HLS. Specifically, the 2018 standard requires a more robust integration of energy management into the organization's strategic and operational planning, demanding a clearer understanding of the organizational context and its implications for energy performance. The concept of energy review in the 2018 version is more comprehensive, requiring a deeper analysis of energy uses and consumption, identification of significant energy uses, SU, and the establishment of energy baselines and performance indicators, NPI, that are directly linked to strategic objectives. The 2011 version, while containing similar elements, was less prescriptive about the integration with strategic business goals and the specific requirements for understanding the organizational context and interested parties' needs concerning energy performance. Therefore, a gap analysis must meticulously identify where the existing 2011 system falls short in meeting these enhanced requirements for strategic integration, contextual analysis, and the detailed energy review mandated by the 2018 revision. The specific requirement for establishing a framework for achieving energy objectives and managing energy performance, as detailed in Clause 6.2 of the 2018 standard, necessitates a thorough review of how the 2011 system's planning processes align with these more strategic and integrated demands. Question 3. When refining an energy baseline established under ISO 50001-2018, an organization observes a significant increase in production output following the baseline period. To accurately assess the impact of newly implemented energy-saving technologies, what is the most critical consideration for adjusting the baseline to reflect this change in production volume? Option A. Modifying the baseline to reflect the average production volume across the entire organization, irrespective of which specific production lines utilize the new technologies. Option B. Applying a simple linear scaling factor based on the percentage increase in production, assuming a direct proportionality between output and energy use for all processes. Option C. Ensuring the adjustment method accounts for the non-linear relationship between production volume and energy consumption, thereby isolating the efficiency gains from the increased operational scale. Option D. Overriding the established baseline entirely and recalculating it from scratch using only data from the post-implementation period to avoid any potential baseline drift. The correct answer is C. Ensuring the adjustment method accounts for the non-linear relationship between production volume and energy consumption, thereby isolating the efficiency gains from the increased operational scale. Explanation. The core principle behind establishing an energy baseline in ISO 50001-2018 is to provide a reference point against which energy performance can be measured and improved. This baseline should reflect a period of stable operation, allowing for accurate comparison of energy consumption before and after the implementation of energy management measures. The standard emphasizes the use of relevant variables that influence energy consumption, known as energy performance indicators, NPI. These variables can be static or dynamic. Static variables are those that do not change significantly over the period of the baseline or are generally constant, such as the physical size of a facility or the type of primary machinery installed. Dynamic variables, however, are those that fluctuate and directly impact energy use, such as production volume, outdoor temperature, occupancy levels, or operating hours. When adjusting the baseline to account for changes in these influencing variables, the goal is to isolate the impact of the energy management measures. For instance, if production volume increases, energy consumption is expected to rise. A properly adjusted baseline will account for this increase in production, allowing the organization to determine if the energy management measures have led to a reduction in energy consumption per unit of production, rather than simply observing a lower total energy bill due to decreased production. The adjustment process ensures that the comparison of energy performance is fair and accurately reflects the effectiveness of the implemented actions. The selection of variables for adjustment must be based on their statistical significance and their causal relationship with energy consumption, as determined through data analysis. The standard requires that the baseline be documented and that the methodology for adjustment be clearly defined and applied consistently. Question 4. When an organization seeks to integrate its newly implemented ISO 50001, 2018 compliant energy management system with its existing ISO 9001, 2015 quality management system, what is the most significant strategic advantage gained through this integration concerning the management review process? Option A. A mandated simplification of the energy review process, allowing for the exclusion of specific energy performance indicators deemed less critical to overall quality objectives. Option B. The ability to use quality control data as direct input for energy performance indicators without requiring further validation, streamlining the energy review process. Option C. The automatic alignment of all quality objectives with energy performance targets, eliminating the need for separate energy-specific strategic planning. Option D. Consolidation of management review meetings to address quality and energy performance objectives and data within a single, comprehensive session, thereby reducing audit frequency and administrative overhead. The correct answer is D. Consolidation of management review meetings to address quality and energy performance objectives and data within a single comprehensive session, thereby reducing audit frequency and administrative overhead. Explanation: the integration of an energy management system, NMS, with other management systems, such as those for quality ISO 9001 or environmental management, ISO 14001, leverages common elements to create a more efficient and cohesive organizational approach. ISO 50001, 2018, like other ISO management system standards, is structured around the Annex SL high-level structure. This common structure facilitates integration by sharing clauses related to context of the organization, leadership, planning, support, operation, performance evaluation, and improvement. When integrating, organizations aim to align policies, objectives, processes, and documentation. For example, the management review process required by ISO 50001 can be combined with the management reviews for ISO 9001 and ISO 14001, addressing energy performance, quality performance, and environmental performance within a single, comprehensive review. Similarly, internal audits can be conducted to cover multiple standards simultaneously, reducing duplication of effort and resources. The establishment of an integrated management system, IMS, requires careful planning to ensure that the specific requirements of each standard are met while capitalizing on synergies. This often involves creating a common framework for risk and opportunity management, document control, and communication that serves all integrated systems. The benefit of such integration is a streamlined approach to management, reduced administrative burden, and a more holistic view of organizational performance and sustainability. The key is to ensure that the specific energy management aspects, including energy review, energy baselines, and performance indicators, are adequately addressed within the integrated framework, rather than being diluted or overlooked. Question 5. An industrial facility transitioning to ISO 50001, 2018 has identified its primary significant energy use as the operation of large-scale extrusion presses. The facility's production volume fluctuates weekly based on market demand. To effectively monitor and demonstrate improvements in energy performance, which energy performance indicator NPI will most accurately reflect the efficiency gains achieved through new operational protocols and equipment upgrades related to these presses. Option A, percentage reduction in total energy bills for the extrusion department. Option B, kilowatt-hours consumed per kilogram of extruded product. Option C, average kilowatt-hours consumed per hour of press operation. Option D, total kilowatt-hours consumed by the extrusion presses per week. The correct answer is B, kilowatt-hours consumed per kilogram of extruded product. Explanation: the core principle behind selecting appropriate energy performance indicators, NPI, in ISO 50001, 2018, particularly during a transition, is their ability to demonstrate significant improvement in energy performance. NPIs must be quantifiable and allow for the monitoring of energy consumption and efficiency in relation to relevant variables. Clause 6.2.3, Energy Review, and Clause 6.2.4, Energy Baselines and Energy Performance Indicators, of ISO 50001, 2018 are critical here. The standard emphasizes that NPIs should be established for significant energy uses and other relevant energy services. When considering a transition, The focus is on demonstrating progress against established baselines, an NPI that directly correlates energy consumption to a key operational factor, such as production output or operational hours, and shows a downward trend in energy consumed per unit of output or activity, directly reflects improved energy performance. This type of NPI is robust because it accounts for changes in operational scale. For instance, if an organization produces more units, its total energy consumption might increase. But if the energy consumed per unit decreases significantly, this indicates improved efficiency. Therefore, an NPI that quantifies energy consumption per unit of manufactured product, when that unit of product is a primary driver of energy use, is the most effective for demonstrating the impact of energy management activities and the success of the transition towards better energy performance. This directly addresses the standard's requirement to measure and monitor energy performance in a way that reflects the effectiveness of implemented energy-saving measures. Question 6. During the transition of an energy management system to ISO 50001-2018, a manufacturing facility plans to install a new, highly efficient automated packaging line. This line represents a significant new energy-consuming asset. Which of the following actions best demonstrates adherence to the requirements of Clause 8? 1. Operational planning and control, concerning the integration of this new equipment into the NMS. Option A. Update the NMS documentation to include specific operational procedures, maintenance schedules, and performance monitoring protocols for the new packaging line, ensuring alignment with established energy baselines and targets. Option B. Conduct a one-time training session for the operators of the new packaging line on general energy-saving practices without formal integration into the NMS operational controls. Option C. Document the initial energy consumption of the new packaging line as a separate, isolated data point, without linking it to the overall NMS operational controls or performance improvement plans. Option D. Rely solely on the equipment manufacturer's recommended operating settings, assuming they inherently guarantee optimal energy performance within the facility's context. The correct answer is A. Update the NMS documentation to include specific operational procedures, maintenance schedules, and performance monitoring protocols for the new packaging line, ensuring alignment with established energy baselines and targets. Explanation: the transition to ISO 50001-2018 requires organizations to update their energy management system, NMS, to align with the revised requirements. Clause 8.1. Operational planning and control specifically mandates that an organization shall establish, implement, and control the processes needed to meet its energy performance improvement requirements, and to implement the actions identified in Clause 6. This includes controlling operational variables, implementing procedures for operation and maintenance, and managing changes. When considering the integration of new energy-consuming equipment, such as advanced HVAC systems, into an existing NMS, the organization must ensure that the planning and control processes adequately address the energy implications. This involves identifying significant energy uses, SU, associated with the new equipment, establishing baseline energy consumption, setting energy performance indicators, NPI, and targets for the equipment, and implementing procedures for its operation and maintenance to ensure optimal energy performance. The transition process, as guided by the standard, emphasizes a systematic approach to managing energy, which includes planning for new assets and modifying existing processes to achieve energy savings. Therefore, the most appropriate action during the transition, when introducing new equipment, is to integrate its operational parameters and maintenance requirements into the established NMS procedures, thereby ensuring continued and improved energy performance. This proactive integration aligns with the standard's intent to embed energy management into daily operations and decision-making. Question 7. Consider an organization that has successfully implemented ISO 50001-2011. Following the release of ISO 50001-2018, the organization is undertaking the transition. Concurrently, their primary manufacturing process, identified as a significant energy use, has been significantly upgraded with new, highly automated machinery that operates under different parameters and has distinct startup and shutdown sequences compared to the previous equipment. What is the most critical action the organization must take concerning its operational planning and control to ensure continued compliance and effective energy management during this transition period, given these simultaneous changes? Option A. Revise operational controls to reflect the new machinery's operating parameters, start-up, shut-down, and potential for deviation from optimal energy performance. Option B. Focus solely on updating the organization's energy policy and objectives to align with the 2018 version of the standard, deferring operational control updates. Option C. Document the new machinery's energy consumption data, but refrain from implementing new operational controls until a full year of performance data is collected. Option D. Continue to apply the existing operational controls from the ISO 50001-2011 system, assuming they are sufficiently robust for the new equipment. Correct answer is A. Revise operational controls to reflect the new machinery's operating parameters, start-up, shut-down, and potential for deviation from optimal energy performance. Explanation: the transition from ISO 50001-2011 to ISO 50001-2018 necessitates a thorough review and potential revision of an organization's energy management system, NMS. Clause 6.4 of ISO 50001-2018, Operational Planning, Control, and Operation, requires organizations to plan, implement, and control the processes needed to meet the requirements of the NMS and to implement the actions determined in Clause 6. 1. Actions to address risks and opportunities. Specifically, it mandates that organizations establish, implement, and maintain processes for operating and controlling the identified significant energy uses, SIU, and other energy uses that can lead to significant deviations in energy performance. This includes establishing controls to prevent unintended deviations. When considering the transition, an organization must ensure that its existing operational controls, particularly those related to energy, are reviewed against the updated requirements. If the organization's primary manufacturing process, which is the source of its significant energy use, has undergone a substantial technological upgrade that alters its fundamental energy consumption patterns and operational parameters, the existing controls might no longer be adequate. For instance, if a new, more energy-efficient but also more complex machinery has been introduced, the previous control measures for energy consumption might not account for the new operating modes, startup procedures, or potential for inefficient operation under specific conditions. Therefore, a review and potential update of these operational controls are essential to maintain effective energy management and ensure that energy performance is not negatively impacted by the technological change. This proactive adjustment aligns with the standard's emphasis on continuous improvement and adapting the NMS to changing circumstances. Question 8. When transitioning to an ISO 50001-2018 compliant energy management system, what primary criterion distinguishes an energy use as significant beyond simply its total energy consumption volume? Option A. Its potential to impact the organization's ability to achieve its energy performance objectives and its contribution to overall energy costs. Option B. The frequency of maintenance activities required for the energy-consuming equipment. Option C. The age and technological sophistication of the equipment consuming the energy. Option D. The number of personnel directly involved in operating the equipment associated with the energy use. The correct answer is A. Its potential to impact the organization's ability to achieve its energy performance objectives and its contribution to overall energy costs. Explanation: the process of identifying significant energy uses, SIU, within an organization's energy management system, as outlined by ISO 50001-2018, requires a systematic approach that considers both the magnitude of energy consumption and its impact on operational performance. This involves analyzing energy data, understanding energy performance indicators, NPI, and evaluating the contribution of various energy uses to overall energy consumption and costs. A key aspect is to differentiate between mere large energy consumers and those that are truly significant from an energy management perspective. Significance is determined not just by the volume of energy consumed, but also by its variability, its impact on business objectives, and its potential for improvement. For instance, a large energy-consuming process that is highly stable, well-controlled, and has limited scope for optimization might be less significant in an energy management context than a smaller, but highly variable and inefficient process with substantial potential for energy savings. Therefore, The identification of SEUs is a dynamic process that should be reviewed and updated as the organization's operations and energy landscape evolve. This aligns with the standard's emphasis on continuous improvement of energy performance. The consideration of relevant legal and other requirements, such as energy efficiency directives or local environmental regulations, is also integral to determining significance, as non-compliance can lead to significant financial and reputational consequences. Question 9. When establishing an energy baseline for a manufacturing facility transitioning to ISO 50001-2018, a critical step involves using regression analysis to model energy consumption. Consider a scenario where initial analysis reveals that production output is the primary driver of electricity usage. However, further investigation suggests that ambient temperature also has a statistically significant, albeit secondary, influence on the cooling system's energy demand, which contributes to the facility's overall electricity consumption. The regression model, initially developed, only incorporates production output. Which of the following best describes the potential consequence of using this simplified model for the energy baseline, and what action would be most appropriate to ensure the baseline's integrity and the effectiveness of subsequent performance monitoring? Option A. The baseline may not accurately reflect actual energy consumption under varying ambient temperature conditions, potentially masking or overstating energy savings achieved through efficiency measures, and the model should be refined to include ambient temperature as a significant variable. Option B. The baseline will be overly sensitive to production fluctuations, leading to an underestimation of energy savings, and the organization should focus solely on controlling production levels rather than refining the baseline model. Option C. The baseline will be inherently flawed because regression analysis is only suitable for single-variable relationships, necessitating a complete abandonment of this modeling approach in favor of simpler historical averages. Option D. The baseline will be perfectly accurate as long as production output is the dominant variable, and any influence from ambient temperature is negligible and can be ignored for the purposes of ISO 50001-2018 compliance. The correct answer is A. The baseline may not accurately reflect actual energy consumption under varying ambient temperature conditions, potentially masking or overstating energy savings achieved through efficiency measures, and the model should be refined to include ambient temperature as a significant variable. Explanation: the development of an energy baseline using regression analysis in ISO 50001-2018 requires careful consideration of the variables that influence energy consumption. The standard emphasizes that the baseline should be representative of the energy performance of the relevant energy uses. Regression analysis helps to establish a relationship between energy consumption and key variables that affect it, such as production volume, operating hours, or climate data. For a baseline to be robust and suitable for measuring improvements, it must account for significant variations in these variables. If the regression model does not adequately capture the impact of these influencing factors, the baseline will not accurately reflect the energy performance under different operational conditions. Consequently, any subsequent energy performance indicators, NPI, derived from such a flawed baseline would be unreliable, making it difficult to demonstrate genuine energy savings. A well-developed baseline, therefore, is one that has a strong statistical fit, meaning the independent variables explain a significant portion of the variation in energy consumption, and the model is validated against actual data. The primary purpose of regression in this context is to isolate the impact of energy management initiatives from the influence of external or operational factors. This allows for a more accurate assessment of whether changes in energy consumption are due to implemented improvements or simply changes in production or other influencing factors. The regression equation \text energy consumption equals F \text variable 1 \text variable 2 \text variable n quantifies this relationship. The quality of the baseline is directly linked to the selection of appropriate variables and the statistical validity of the regression model. Question 10. Consider an industrial manufacturing firm, Ethelred Metalworks, that is undertaking its transition to ISO 50001-2018. The organization has identified its most significant energy uses, including furnace operations, compressed air systems, and lighting across its production facilities. To effectively implement the revised awareness requirements of the standard, what is the most crucial element to incorporate into their training and awareness program for all employees, from shop floor operators to senior management? Option A, focusing solely on the technical specifications of energy-efficient equipment and technologies available in the market. Option B, demonstrating how individual roles and daily tasks directly influence the organization's energy performance and the achievement of its energy objectives. Option C, distributing copies of the full ISO 50001-2018 standard document to every employee for their personal study. Option D, providing a detailed historical overview of energy management standards and the evolution of ISO 50001. The correct answer is B, demonstrating how individual roles and daily tasks directly influence the organization's energy performance and the achievement of its energy objectives. Explanation: the transition to ISO 50001-2018 requires a thorough understanding of the revised requirements, particularly concerning the integration of energy management into broader organizational processes and the emphasis on performance indicators and baselines. Clause 7.2, competence, and Clause 7.3, awareness, are critical for ensuring that all personnel understand their roles and contributions to the Energy Management System, NMS. For a successful transition, the awareness program must go beyond mere dissemination of information about the standard's existence. It needs to foster a genuine understanding of how the organization's energy performance is affected by individual actions and departmental operations. This includes making personnel aware of significant energy uses, SU, the energy policy, their specific contributions to the effectiveness of the NMS, and the benefits of improved energy performance. Furthermore, the program must address the implications of the revised standard, such as the enhanced focus on strategic energy management and the importance of data-driven decision-making. Key aspect of awareness is ensuring that employees at all levels comprehend how their daily activities, from operating machinery to managing facilities, directly or indirectly impact energy consumption and overall energy performance. This understanding is foundational for driving behavioral change and achieving the organization's energy objectives, which is a core tenet of the ISO 50001-2018 standard. Question 11. A manufacturing facility is planning a significant upgrade to its production line, involving the installation of new machinery and a complete overhaul of its HVAC system. To ensure the upgrade aligns with ISO 50001-2018 principles, which approach to design and procurement best supports the organization's energy performance objectives. Option A, focusing solely on the initial capital cost of the new machinery and HVAC system, with energy efficiency being a secondary consideration only if it does not significantly increase upfront expenditure. Option B, procuring the most technologically advanced machinery and HVAC system available, assuming that higher technology inherently guarantees superior energy performance without specific verification or integration into design. Option C, conducting an energy audit after the installation of the new equipment to identify potential energy savings opportunities, and then retrofitting existing systems to improve their energy performance. Option D, integrating energy performance requirements into the design specifications for the new machinery and HVAC system, and establishing procurement criteria that prioritize suppliers with proven energy efficiency track records and products certified for energy performance. The correct answer is D, integrating energy performance requirements into the design specifications for the new machinery and HVAC system, and establishing procurement criteria that prioritize suppliers with proven energy efficiency track records and products certified for energy performance. Explanation: the transition to ISO 50001-2018 from an earlier version or a non-certified state emphasizes the integration of energy performance considerations into the design and procurement processes. Clause 7.3, design, and Clause 7.4, procurement of ISO 50001-2018 are crucial here. Clause 7.3 requires the organization to establish processes for the design of new or modified energy uses, energy services, and energy management systems, ensuring that energy performance is considered. This includes incorporating energy performance requirements into the design specifications for new equipment, facilities, or processes. Clause 7.4 mandates that when procuring products and services that impact energy performance, The organization must ensure that these procurements are consistent with its energy policy and that energy performance is considered. This means establishing criteria for energy performance in procurement specifications and evaluating suppliers based on their ability to meet these criteria. The goal is to proactively improve energy performance by making informed decisions during the design and acquisition phases, rather than solely relying on operational improvements. Therefore, ensuring that energy performance criteria are explicitly integrated into the specifications for new HVAC systems during the procurement process, and that the design of the building's envelope complements these systems, directly addresses the intent of these clauses. This proactive approach is fundamental to achieving sustained energy performance improvements. Question 12. When an organization is transitioning its energy management system from ISO 50001-2011 to ISO 50001-2018, what is a primary shift in the support requirements that necessitates a reevaluation of existing human resource development and communication protocols? Option A. The explicit need to document all energy-saving projects in a specific, standardized format provided by the International Organization for Standardization, limiting organizational flexibility. Option B. The requirement to establish a formal energy purchasing policy that dictates the source and type of all energy consumed by the organization, mandating renewable energy procurement. Option C. The introduction of a mandatory energy review cycle that must be conducted annually, irrespective of the organization's operational complexity or energy consumption patterns. Option D. The increased emphasis on competence and awareness for all personnel involved in energy-related activities, coupled with a more structured approach to internal and external communication concerning energy performance. The correct answer is D. The increased emphasis on competence and awareness for all personnel involved in energy-related activities, coupled with a more structured approach to internal and external communication concerning energy performance. Explanation. The transition from ISO 50001-2011 to ISO 50001-2018 introduced several significant changes, particularly in the support requirements. Clause 7. Support was restructured and expanded. A key aspect of this transition is the enhanced focus on competence and awareness, as well as the requirement for documented information. Specifically, the 2018 version places a greater emphasis on ensuring that personnel are competent and aware of their roles and responsibilities concerning energy performance. This includes understanding the significance of deviations from the intended operational conditions and the implications of their individual actions on the energy management system. Furthermore, the standard now requires organizations to determine and provide the necessary resources for the establishment, implementation, maintenance, and continual improvement of the energy management system. This encompasses not only physical resources, but also human resources and knowledge. The requirement for documented information is also more flexible, allowing for various formats and media, but it must be controlled and maintained. The emphasis on communication, both internal and external, is also strengthened, requiring organizations to determine what, when, how, and with whom communication should take place regarding their energy management system. The integration of energy management into the organization's strategic planning and operational processes is also a critical consideration during the transition, requiring a comprehensive understanding of the organizational context and the needs and expectations of interested parties. The updated standard also introduces a more explicit requirement for management commitment and leadership, ensuring that energy management is integrated into the business strategy. Question 13. A global automotive component manufacturer, having successfully transitioned to ISO 50001-2018, is conducting an internal audit of its new employee onboarding process for assembly line technicians. The audit report highlights a gap. While technicians are proficient in operating the automated assembly machinery, their understanding of how specific operational parameters e.g., cycle times, idle periods, and material handling efficiency directly impact the facility's energy performance indicators, NPI, and contribute to overarching energy objectives is limited. This lack of awareness could undermine the effectiveness of the NMS. Considering the requirements of ISO 50001-2018, which strategy would most effectively address this identified competence and awareness gap for new technicians? Option A. Develop and implement a dedicated training module for new assembly line technicians that explicitly links operational parameters, machine settings, and material flow to the facility's NPIs and energy objectives, including practical examples of energy wastage from non-optimal practices. Option B. Conduct annual refresher training for all existing employees on energy management, which new technicians will attend, thereby indirectly addressing their awareness through exposure to broader energy management topics. Option C. Update the machinery operation manuals to include a separate section on energy-efficient operation, expecting technicians to independently study and apply this information without structured training or verification of understanding. Option D. Rely on the existing general awareness sessions conducted by the Environmental Health and Safety Department to cover energy management principles, assuming that relevant information will be absorbed by new technicians through osmosis. The correct answer is A. Develop and implement a dedicated training module for new assembly line technicians that explicitly links operational parameters, machine settings, and material flow to the facility's NPIs and energy objectives, including practical examples of energy wastage from non-optimal practices. Explanation. The transition to ISO 50001-2018 requires organizations to establish, implement, maintain, and continually improve an energy management system, NMS. A critical aspect of this is ensuring personnel are competent, trained, and aware of their roles and contributions to the NMS. Clause 7.2. Competence mandates that the organization determine the necessary competence for personnel doing work under its control that affects its energy performance and the NMS. It also requires the organization to ensure these persons are competent on the basis of appropriate education, training, or experience, and to take action to acquire the necessary competence, where applicable. Furthermore, Clause 7.3. Awareness requires that persons doing work under the organization's control are aware of the energy policy, relevant aspects of their work affecting energy performance, the benefits of improved energy performance, and implications of not conforming with the NMS requirements. The scenario describes a manufacturing plant that has recently certified to ISO 50001-2018. The energy manager is reviewing the effectiveness of their training program for new production line operators. They are concerned that operators, while trained on machine operation, may not fully grasp how their specific actions directly influence energy consumption and the overall energy objectives. The organization must ensure that training addresses not just operational tasks, but also the impact of those tasks on energy performance and the NMS. This includes understanding how deviations from standard operating procedures, such as inefficient startup or shutdown sequences, or improper machine settings, can lead to increased energy use, thereby hindering the achievement of energy performance indicators, NPI, and organizational energy objectives. Therefore, the most effective approach to address this concern, in line with ISO 50001-2018 requirements for competence and awareness, is to integrate specific modules within the operator training that detail the link between their daily activities and the plant's energy performance, including the consequences of nonconformance on energy objectives. This ensures they understand the why behind energy-saving practices, fostering a more proactive approach to energy management. Question 14. Consider a large manufacturing facility transitioning to ISO 50001-2018. The facility has identified several significant energy uses, including its compressed air system and HVAC for administrative buildings. To effectively monitor and evaluate their energy performance, which of the following approaches best aligns with the requirements of Clause 6? 4. Emphasizing a holistic and data-driven continuous improvement cycle. Option A. Implementing a system that continuously collects real-time data on compressed air system pressure and flow, alongside hourly HVAC temperature and energy consumption readings, with monthly automated reports flagging deviations from baseline performance and triggering review of operational parameters and maintenance logs. Option B. Relying solely on annual energy bills and end-of-year performance reviews to identify broad trends in energy consumption across all facility operations. Option C. Conducting ad hoc spot checks of energy-consuming equipment and using manual data logging for key performance indicators without establishing a structured process for analysis or evaluation. Option D. Focusing primarily on the installation of new, energy-efficient equipment and assuming improved energy performance without systematically monitoring or measuring the impact of these upgrades. Correct answer is A. implementing a system that continuously collects real-time data on compressed air system pressure and flow, alongside hourly HVAC temperature and energy consumption readings, with monthly automated reports flagging deviations from baseline performance and triggering review of operational parameters and maintenance logs. Explanation: the core of ISO 50001, 2018, particularly in Clause 6, for monitoring, measurement, analysis, and evaluation, is to establish, implement, and maintain a process for monitoring, measuring, analyzing, and evaluating the energy performance of the organization. This involves determining what needs to be monitored and measured, the methods for monitoring, measurement, analysis, and evaluation necessary to achieve the objectives and ensure the reliable results, when monitoring and measuring should be performed, and when the results from monitoring and measurement should be analyzed and evaluated. For significant energy uses, it is crucial to monitor and measure their performance. The standard also requires the organization to evaluate the performance and the effectiveness of the energy management system. This evaluation should consider trends in energy consumption, the achievement of energy objectives and targets, and the effectiveness of energy-saving measures. The analysis of data should support informed decision-making for continuous improvement. This includes understanding the impact of operational changes and identifying opportunities for further energy optimization. The organization must also ensure that calibrated or verified monitoring and measuring equipment is used and maintained. The analysis of energy performance data is not merely about collecting numbers. It is about deriving actionable insights to drive improvements in energy efficiency and overall energy performance. This process is fundamental to demonstrating compliance and achieving the benefits of an energy management system. Question 15. Consider a scenario at a large industrial facility that has transitioned to ISO 50001-2018. Their primary energy performance indicator, NPI, for a critical production line is defined as kWh per ton of product manufactured, with the key operational variable being the average machine uptime percentage. After a period of stable operation, the NPI shows a statistically significant increase, indicating higher energy consumption per ton. However, the average machine uptime percentage has remained consistently within its expected range and has not changed significantly. According to ISO 50001-2018 principles for using NPIs to drive decision-making, what is the most appropriate immediate course of action for the facility's energy management team? Option A. Report the deviation to senior management as an anomaly and await further instructions on how to proceed, without undertaking immediate investigative actions. Option B. Conclude that the NPI is unreliable due to the lack of correlation with the primary operational variable, and adjust the NPI's baseline to reflect the new higher consumption. Option C. Focus solely on increasing machine uptime to see if that indirectly improves the kWh per ton metric, assuming the NPI deviation is a symptom of underlying operational inefficiency. Option D. Initiate a detailed investigation into other potential influencing factors beyond machine uptime that could be affecting energy consumption per ton, such as changes in raw material properties, ambient temperature fluctuations not previously accounted for, or subtle shifts in equipment operating parameters not directly linked to uptime. The correct answer is D. Initiate a detailed investigation into other potential influencing factors beyond machine uptime that could be affecting energy consumption per ton, such as changes in raw material properties, ambient temperature fluctuations not previously accounted for, or subtle shifts in equipment operating parameters not directly linked to uptime. Explanation: the core principle behind using energy performance indicators, NPI, for decision-making in an ISO 50001-2018 context is to establish a robust link between energy consumption, operational variables, and energy performance. When an organization observes a deviation in an NPI that cannot be explained by changes in the relevant variables, it signals a potential issue or opportunity. For instance, if the NPI for a manufacturing process shows an increase in energy consumption per unit of output, but the key operational variable e.g., production volume, has remained constant, this discrepancy warrants investigation. The investigation should focus on identifying the root cause of this unexpected energy performance change. This could involve examining equipment efficiency, maintenance practices, operational procedures, or even external factors not captured by the primary operational variable. The ISO 2018 standard emphasizes the systematic review of energy performance and the identification of areas for improvement. Therefore, when an NPI deviates without a clear correlation to its defined variables, it necessitates a deeper dive into the underlying energy-related activities and their effectiveness. This process of investigation and analysis is crucial for informed decision-making regarding energy efficiency projects, operational adjustments, and the overall improvement of the energy management system. The aim is to understand why the deviation occurred, not just that it occurred. This understanding then guides the selection of appropriate corrective or preventive actions, or the identification of new opportunities for energy saving. Question 16. A manufacturing facility transitioning to ISO 50001-2018 has identified several potential energy-saving initiatives. These range from simple behavioral changes to complex equipment upgrades. To effectively allocate resources and demonstrate early wins, what fundamental principles should guide the prioritization of these actions within the Energy Action Plan, considering both the potential for energy reduction and the ease of implementation? Option A. Prioritize actions with a high potential for energy impact and low feasibility. Option B. Prioritize actions with a low potential for energy impact and low feasibility. Option C. Prioritize actions with a high potential for energy impact and high feasibility. Option D. Prioritize actions with a low potential for energy impact and high feasibility. Correct answer is C. Prioritize actions with a high potential for energy impact and high feasibility. Explanation: the transition from an older standard to ISO 50001-2018 necessitates a strategic approach to energy action plans. Clause 6. 2. Energy objectives and planning to achieve them. Of ISO 50001-2018 requires the organization to establish energy objectives and plan actions to achieve them. When prioritizing these actions, a crucial consideration is the interplay between their potential energy impact and the resources or effort required for implementation. Actions with a high potential for energy savings or performance improvement, coupled with a relatively low level of complexity, cost, or disruption, high feasibility, typically represent the most effective starting point. Conversely, actions with low impact, even if highly feasible, might not warrant immediate attention, and actions with high impact but low feasibility may require phased implementation or further investigation into overcoming barriers. Therefore, the optimal prioritization strategy balances the magnitude of anticipated benefits against the practicalities of execution. This involves a systematic evaluation of each potential action against defined criteria for both impact and feasibility, often utilizing tools like a prioritization matrix. The goal is to allocate resources efficiently towards initiatives that deliver the most significant and achievable energy performance improvements, aligning with the overall energy policy and strategic direction of the organization. Question 17. Consider a large manufacturing facility that has implemented various energy efficiency measures, including upgraded lighting systems and improved insulation in its main production hall. The facility has established an energy performance indicator, NPI, for electricity consumption per unit of finished product. However, during the period of analysis, there was also a significant increase in the average outdoor temperature, leading to increased use of air conditioning and a concurrent shift in production to a product line that inherently requires more energy per unit. Which characteristic of the NPI is most crucial for accurately demonstrating the actual impact of the implemented energy efficiency measures on electricity consumption? Option A. Its direct correlation with the total energy consumed by the facility, irrespective of operational changes. Option B. Its alignment with the specific energy audit recommendations provided by the external consultant. Option C. Its ability to accurately reflect the impact of energy management actions by accounting for significant influencing variables. Option D. Its simplicity in calculation, allowing for rapid data entry and reporting. The correct answer is C. Its ability to accurately reflect the impact of energy management actions by accounting for significant influencing variables. Explanation: the core principle behind effective energy performance indicators, NPI, in ISO 50001-2018 is their ability to reflect changes in energy performance while accounting for relevant variables. An NPI is designed to measure energy consumption relative to a specific output or activity, allowing for the identification of improvements or deteriorations. When establishing NPIs, it is crucial to ensure they are stable, measurable, and capable of demonstrating the impact of energy management activities. The standard emphasizes that NPIs should be used to monitor and measure energy performance, and the establishment of a baseline is a prerequisite for this. The baseline provides a reference point against which performance is measured. The formula for an NPI often takes the form of \text energy consumption / text activity unit \. However, the question probes the underlying principle of what makes an NPI effective for demonstrating improvement, not just its calculation. An NPI's effectiveness in demonstrating improvement is directly linked to its ability to isolate the impact of energy management actions from external influences or changes in operational factors. This means the NPI must be sensitive to energy-saving measures while being normalized for factors like production volume, climate conditions, or operating hours. Without proper normalization, an apparent improvement might simply be due to a reduction in activity, or a genuine improvement might be masked by an increase in a confounding variable. Therefore, the most critical aspect of an NPI for demonstrating performance improvement is its capacity to clearly differentiate the impact of energy management initiatives from other influencing factors. This requires careful selection of variables and appropriate normalization techniques. Question 18. An industrial facility is transitioning to ISO 50001-2018 and is in the process of establishing its energy performance baseline for its primary manufacturing process, a significant energy use. The facility operates multiple shifts, and production output varies daily based on market demand. Additionally, ambient temperature significantly affects the energy required for climate control within the production area. Which of the following actions is most critical to ensure the baseline accurately reflects the relationship between energy consumption and operational factors for effective benchmarking? Option A. Select a single operational parameter, like average daily production, to represent the entire operational context for the baseline. Option B. Focus solely on the energy consumed during periods of peak production, ignoring periods of lower activity and their associated energy use. Option C. Incorporate all significant variables that influence energy consumption, such as production volume, operating hours, and relevant environmental conditions, into the baseline calculation. Option D. Utilize only the total annual energy consumption data from the previous year to establish the baseline, disregarding operational fluctuations. The correct answer is C. Incorporate all significant variables that influence energy consumption, such as production volume, operating hours, and relevant environmental conditions, into the baseline calculation. Explanation. The core principle of benchmarking energy performance within ISO 50001-2018 involves establishing a baseline against which future energy performance can be measured and improved. This baseline is crucial for setting meaningful energy objectives and targets, and for evaluating the effectiveness of energy management measures. When considering the transition to ISO 50001-2018, organizations must ensure their benchmarking approach is robust and aligned with the standard's requirements. Clause 6.2.2 Energy Review mandates the identification of significant energy uses (SU) and the establishment of a baseline. The baseline is defined as a quantitative reference point of energy performance for a defined period, against which current energy performance can be compared. It is essential that the baseline is established using relevant variables that influence energy consumption, such as production output, operating hours, or climate conditions. Without considering these variables, the baseline would not accurately reflect the relationship between energy consumption and operational factors, making it difficult to assess genuine improvements or identify performance deviations. The standard emphasizes that the baseline should be documented and periodically reviewed. A well-established baseline, incorporating relevant variables, allows for the accurate calculation of energy performance indicators, NPI, which are key to demonstrating progress and achieving energy savings. Therefore, the most appropriate action when establishing a baseline for benchmarking under ISO 50001-2018 is to ensure it incorporates all significant variables that impact energy consumption, thereby providing a reliable foundation for performance monitoring and improvement. Question 19. During the transition of its energy management system to ISO 50001-2018, The manufacturing firm Ethelred Industries discovers a previously undocumented but significant energy consumption in its tertiary waste heat recovery system. What is the most critical immediate action the organization must undertake to maintain compliance with the revised standards requirements for managing energy performance? Option A. Initiate a comprehensive review of all existing energy performance indicators to determine if they need adjustment based on the new discovery. Option B. Conduct a feasibility study for energy efficiency improvements solely for the tertiary waste heat recovery system before updating the energy management system. Option C. Revise the energy review to incorporate the newly identified significant energy use, establishing relevant energy performance indicators and operational controls. Option D. Document the new significant energy use in the Operational Procedures Manual without altering the existing energy review or performance indicators. The correct answer is C. Revise the energy review to incorporate the newly identified significant energy use, establishing relevant energy performance indicators and operational controls. Explanation: the transition to ISO 50001-2018 requires a systematic approach to managing energy. A critical aspect of this transition involves integrating new or revised energy performance indicators, NPI, and operational controls that have been identified as significant energy uses, SEU. When an organization identifies a new SEU or revises an existing one, the Energy Management System, NMS, must be updated to reflect these changes. This update involves revising the energy review, establishing or modifying NPIs and energy baselines, and implementing new or updated operational controls. The question asks about the most appropriate action when a previously unrecognized significant energy use is identified during the transition. The revised standard emphasizes the need to incorporate all significant energy uses into the NMS. Therefore, the most logical and compliant step is to update the energy review to include this new SEU, subsequently establishing appropriate NPIs and baselines, and implementing relevant operational controls. This ensures that the NMS accurately reflects the organization's energy landscape and that the new SEU is managed effectively. Failure to integrate this new SEU would mean the NMS is not fully compliant with the standard's requirements for managing all significant energy uses. Question 20. During the transition to ISO 50001-2018, a manufacturing firm identified a significant opportunity to reduce standby energy consumption in its administrative buildings. They set an objective to reduce overall building energy use by 10% within 2 years, and a target of decreasing standby power consumption by 25% in the administrative sector during the same period. Their action plan included implementing smart power strips, staff awareness campaigns on equipment shutdown, and a review of HVAC control schedules. An internal audit post-transition revealed that, while overall building energy use decreased by 8%, standby power reduction in the administrative sector was only 15%. What is the most likely primary deficiency in the firm's approach to energy objectives, targets, and action plans as demonstrated by this outcome? Option A. The action plan lacks sufficient specificity and resource allocation to achieve the ambitious standby power reduction target, leading to a misalignment between the objective, target, and the practical implementation steps. Option B. The energy policy was not updated to reflect the new operational context, causing a disconnect between strategic direction and tactical energy management efforts. Option C. The energy objective was too broad, failing to adequately focus on specific areas of significant energy use that would drive overall performance improvement. Option D. The internal audit team did not correctly interpret the energy data, leading to an inaccurate assessment of the standby power reduction achieved. Correct answer is A. The action plan lacked sufficient specificity and resource allocation to achieve the ambitious standby power reduction target, leading to a misalignment between the objective, target, and the practical implementation steps. Explanation: the core principle of establishing energy objectives and targets under ISO 50001-2018 is to ensure they are measurable, monitored, communicated, and aligned with the organization's energy policy and overall strategic direction. Action plans are the mechanisms to achieve these objectives and targets. When reviewing the effectiveness of an energy management system, NMS, transition, particularly in relation to objectives and targets, the focus should be on how well these elements are integrated into operational processes and how their achievement contributes to the broader energy performance improvement. Key aspect is the demonstration that the action plans are not merely aspirational, but are concrete, resourced, and time-bound initiatives that directly support the stated objectives. Furthermore, the transition process requires a review of existing objectives and targets to ensure they remain relevant and are still appropriate for the improved NMS. This includes considering new energy performance indicators, NPI, that may have been identified during the transition, or changes in operational context that necessitate adjustments. The effectiveness of the action plans is then evaluated based on their contribution to achieving these refined or maintained objectives and targets, and whether the planned improvements in energy performance have materialized. The link between the action plans, the objectives, and the overall energy policy is crucial for demonstrating a robust and effective NMS. Question 21. An energy manager at a large manufacturing facility, transitioning to ISO 50001, 2018, is tasked with ensuring that all personnel understand the implications of national energy efficiency regulations on their daily operations. The facility has diverse roles, from machine operators to senior management, each with varying levels of direct impact on energy consumption. The energy manager is considering several methods to communicate these legal requirements, which approach best aligns with the intent of ISO 50001, 2018, for ensuring awareness and competence regarding legal obligations affecting energy performance. Option A. Developing role-specific training modules that detail how relevant legal requirements directly impact individual job functions and responsibilities, coupled with regular internal communication campaigns that highlight compliance successes and areas for improvement. Option B. Conducting a single, mandatory all-hands meeting annually to present an overview of all national energy regulations and their general importance to the company. Option C. Publishing a comprehensive document listing all applicable energy laws and regulations on the company intranet and requiring all employees to acknowledge receipt. Option D. Providing all employees with access to the official government websites containing the full text of all energy-related legislation and expecting them to self-educate. The correct answer is A. Developing role-specific training modules that detail how relevant legal requirements directly impact individual job functions and responsibilities, coupled with regular internal communication campaigns that highlight compliance successes and areas for improvement. Explanation: the core of effective communication of legal requirements within an ISO 50001, 2018 energy management system lies in ensuring that relevant personnel are not only aware of these obligations, but also understand their implications for their specific roles and the organization's energy performance. Clause 6. 1. 3 of ISO 50001, 2018 mandates that the organization shall establish, implement, and maintain a process to identify and have access to applicable legal and other requirements related to its energy performance, energy uses, and energy management system. Furthermore, Clause 7. 3. Training, awareness, and competence requires that relevant personnel shall be made aware of the significant energy uses and the implications of their work on energy performance, and importantly, of their contribution to the effectiveness of the energy management system, including the benefits of improved energy performance. This implies a proactive and tailored approach to communication. Simply posting a list of regulations or providing generic training is insufficient. The organization must ensure that the communication is understood and actionable by those who influence energy performance. This involves translating the legal mandates into practical guidance and responsibilities for different job functions, such as operators, maintenance staff, procurement specialists, and management. The effectiveness of this communication is then verified through the organization's monitoring and measurement processes and audits. Therefore, the most robust method involves ensuring that the information is not only disseminated, but also understood and integrated into daily activities and decision-making, thereby fostering a culture of compliance and continuous improvement in energy management. Question 22. An industrial manufacturing firm transitioning to ISO 50001, 2018 has drafted a new energy policy. This policy states a commitment to reducing overall energy consumption by 15% within 3 years and outlines specific actions for operational efficiency. However, the company's strategic plan recently shifted to prioritize market expansion, which may involve acquiring new facilities with potentially different energy profiles and operational complexities, which fundamental aspect of the ISO 50001/2018 energy policy is most likely compromised if the energy policy is not reviewed and updated to reflect this strategic shift. Option A. Documenting the energy policy to ensure it is readily available to all employees and relevant interested parties. Option B. Assigning specific responsibilities for energy management activities to designated personnel within the organization. Option C. Establishing a clear process for monitoring and measuring energy performance indicators across all organizational units. Option D. Ensuring the energy policy provides a framework for setting energy objectives and targets that are consistent with the organization's strategic direction. The correct answer is D. Ensuring the energy policy provides a framework for setting energy objectives and targets that are consistent with the organization's strategic direction. Explanation: the energy policy is a cornerstone of an ISO 50001/2018 energy management system. It serves as the guiding document that sets the organization's commitment to energy performance improvement. Clause 5.2 of the standard energy policy mandates that top management establish, implement, and maintain an energy policy that is appropriate to the purpose and context of the organization. This policy must include a commitment to the continual improvement of energy performance, energy efficiency, and energy conservation. Furthermore, it needs to provide a framework for setting energy objectives and energy targets. A critical aspect of the energy policy's effectiveness is its alignment with the organization's overall strategic direction and business objectives. This ensures that energy management is integrated into the core operations and decision-making processes, rather than being treated as a separate initiative. The policy must also be communicated within the organization and made available to interested parties. The transition to ISO 50001/2018 specifically emphasizes the need for this policy to reflect the updated requirements and the enhanced focus on strategic integration. Therefore, ensuring the energy policy is a living document that guides strategic energy decisions and reflects the organization's commitment to continuous improvement is paramount. The policy must also consider relevant legal requirements and other requirements to which the organization subscribes. Question 23. Consider an industrial facility that has implemented various energy efficiency measures. To accurately assess the impact of these measures, the organization needs to normalize its electricity consumption data. They have identified that both the total production volume, in units, and the average outdoor temperature, in degrees Celsius, significantly influence their electricity usage. Their baseline period data shows an average electricity consumption of 500 MWh per month, with an average production of 10,000 units and an average outdoor temperature of 15 degrees C. In the current period, they consumed 520 MWh, produced 11,000 units, and the average outdoor temperature was 18 degrees C. If the established normalization model indicates that for every 1,000 unit increase in production, electricity consumption increases by 10 MWh, and for every 1 degree C increase in average outdoor temperature, consumption increases by 2 MWh. What is the normalized electricity consumption for the current period? Option A, 490 MWh. Option B, 505 MWh. Option C, 530 MWh. Option D, 515 MWh. The correct answer is A, 490 MWh. Explanation: the core principle of energy data normalization in ISO 50001/2018 is to adjust energy consumption figures to account for variations in influencing factors, thereby enabling meaningful comparisons of energy performance over time. This process aims to isolate the impact of energy management activities from external or operational changes. Key to normalization is the identification of relevant variables that significantly affect energy consumption. These variables can include production output, climate conditions e.g., heating degree days, cooling degree days, operating hours, occupancy levels, or even product mix. The standard emphasizes establishing a baseline period and developing a model that relates energy consumption to these identified variables. This model allows for the calculation of normalized energy consumption, which represents the energy that would have been consumed under a standardized set of conditions. For example, if a manufacturing plant increases its production volume, its energy consumption will likely rise. Normalization would involve adjusting the recorded energy consumption to reflect the energy that would have been used at a baseline production level, allowing for a clearer assessment of efficiency improvements independent of production changes. The identification and selection of appropriate normalization variables are crucial and should be based on a thorough understanding of the organization's energy use and its key drivers. The aim is to create a consistent metric that reflects the true impact of energy management efforts. Question 24. Consider an industrial facility that operates on a continuous 24/7 basis, but experiences a predictable, significant increase in production output during the summer months due to seasonal market demand, leading to higher energy consumption. When establishing the energy baseline for this facility, in accordance with ISO 50001/2018, what is the most critical consideration for ensuring the baseline accurately reflects normal operating conditions for performance measurement? Option A. Utilizing a baseline period that excludes the summer months to avoid artificially inflating the baseline due to peak production. Option B. Selecting a baseline period that encompasses a full annual cycle to capture the full range of operational variations and seasonal influences on energy consumption. Option C. Choosing a baseline period that aligns with the most recent financial reporting year, regardless of operational fluctuations, to simplify data aggregation. Option D. Focusing solely on periods of lowest energy consumption to establish a more conservative and achievable target for future improvements. Correct answer is B. Selecting a baseline period that encompasses a full annual cycle to capture the full range of operational variations and seasonal influences on energy consumption. Explanation. The selection of an appropriate baseline period is fundamental to establishing meaningful energy performance indicators, NPI, and setting energy objectives within an ISO 50001/2018 energy management system, NMS. Baseline period serves as a reference point against which energy performance is measured and evaluated for improvements. Clause 6, 2, 3 of ISO 50001/2018, which deals with operational planning, procedure development and operation, and the establishment of energy baselines and energy performance indicators, mandates that an energy baseline shall be established for significant energy uses. The baseline should reflect a period of normal operation and be representative of the energy consumption patterns and influencing factors relevant to the energy uses being monitored. When selecting a baseline period, several factors must be considered to ensure its validity and utility. These include the availability and reliability of historical energy data, the stability of the organization's operations and production levels during the proposed period, and the influence of relevant variables that impact energy consumption. For instance, if an organization experiences significant seasonal variations in production or operational hours, a single month or quarter might not be representative. Instead, a longer period, such as a full year or even multiple years, may be necessary to capture these variations and establish a robust baseline. The chosen period should also be free from unusual events or operational disruptions that could skew the energy consumption data, making it an unreliable reference point for future performance evaluation. Furthermore, the baseline must be documented and reviewed periodically, especially if significant changes occur in the organization's operations, facilities, or the influencing factors that were initially identified. This ensures that the baseline remains relevant and continues to support the effective management of energy performance. The process of selecting a baseline period is iterative and requires careful analysis of energy data and operational context to ensure it accurately reflects the organization's energy consumption patterns. Question 25. Consider an industrial facility transitioning to ISO 50001/2018. The facility has identified its primary energy consumers and has collected data on electricity and natural gas consumption over the past 3 years, alongside production output and ambient temperature records. Which of the following best describes the crucial step in establishing a reliable energy baseline for future performance comparisons and for identifying significant energy uses, SU, in accordance with the standard? Option A. Focusing solely on reducing the highest electricity consumption points identified in the first year of data collection, without establishing a comprehensive baseline or considering other energy sources. Option B, conducting a one-time audit of all energy-consuming equipment to compile a static list of all energy uses, regardless of their impact on overall consumption. Option C, averaging the total energy consumption over the past 3 years to establish a fixed reference point, without considering any influencing factors or specific consumption areas. Option D, developing a dynamic energy baseline that correlates historical energy consumption with key operational and external variables, and subsequently identifying SEUs based on their contribution to this baseline. The correct answer is D, developing a dynamic energy baseline that correlates historical energy consumption with key operational and external variables, and subsequently identifying SEUs based on their contribution to this baseline. Explanation. The core principle of understanding energy use patterns under ISO 50001-2018 involves establishing a baseline and then monitoring significant energy uses, SEU. A baseline is a reference point against which energy performance is compared. Establishing this baseline requires collecting and analyzing historical energy consumption data, along with relevant variables that influence energy use, such as production levels, operating hours, or climatic conditions. The standard emphasizes that this baseline should be dynamic, meaning it can be revised if significant changes occur in the influencing variables or the energy system itself. Monitoring SEUs involves systematically tracking energy consumption for those areas identified as having the greatest impact on overall energy performance. This monitoring allows for the identification of trends, anomalies, and opportunities for improvement. The process is iterative. The baseline and SEU data inform the development of energy objectives and targets, and the results of monitoring are used to evaluate the effectiveness of implemented energy performance improvements. Without a robust baseline and ongoing monitoring of SEUs, it is impossible to accurately assess whether energy performance is improving or declining, which is a fundamental requirement of the standard. The relationship between energy consumption and influencing variables is crucial for understanding deviations from expected performance and for setting realistic improvement targets. Question 26. Consider a large industrial complex with multiple production lines, each utilizing various types of machinery that consume electricity and natural gas. The facility's energy management team is transitioning to ISO 50001-2018 and is focusing on identifying its significant energy uses, SEU. They have access to monthly utility bills for the entire complex and basic operational data, such as total production volume per line. What fundamental aspect of data collection and analysis is most crucial for accurately identifying SEUs in this scenario, beyond simply aggregating total energy consumption? Option A. Disaggregating energy consumption data by specific production lines, equipment types, and operational drivers to establish a baseline for each potential SEU. Option B. Conducting a one-time audit of major equipment without continuous data collection to identify SEUs. Option C. Utilizing external energy consultants to provide a generic list of common SEUs applicable to similar industries without specific facility data. Option D. Relying solely on the total monthly energy consumption figures from utility bills to rank energy uses by magnitude. The correct answer is A. Disaggregating energy consumption data by specific production lines, equipment types, and operational drivers to establish a baseline for each potential SEU. Explanation. The transition to ISO 50001-2018 necessitates a robust approach to collecting and analyzing energy data, particularly concerning significant energy uses, SEU. Clause 6.4.3 of the standard mandates that an organization shall establish a process for collecting the necessary data to implement the energy management process and to determine the significant energy uses. This process must ensure the data collected is appropriate in terms of accuracy, precision, and level of detail for the intended use. When identifying SEUs, an organization needs to consider not just direct energy consumption, but also factors that influence it. For instance, if a manufacturing facility uses steam for multiple processes, simply measuring the total steam consumption might not be sufficient to identify the SEUs accurately. Instead, the organization should aim to collect data that allows for the disaggregation of steam usage by specific processes or production lines. This might involve installing submeters, analyzing production output linked to steam consumption, or using operational data such as operating hours for specific equipment. The analysis of this data, often involving trend analysis, benchmarking, and correlation with operational variables, helps in pinpointing which energy uses have the most significant impact on the organization's overall energy performance. Without this granular data, the effectiveness of energy-saving initiatives targeted at SEUs will be compromised, hindering the organization's ability to achieve its energy performance objectives and targets as required by Clause 6. 2. 1. Therefore, the foundation of effective SEU identification and management lies in a well-defined and executed data collection and analysis strategy that captures the nuances of energy consumption across different operational activities. Question 27. A nation's environmental agency enacts a new decree requiring all manufacturing plants exceeding a certain annual energy consumption threshold to submit detailed quarterly reports on their primary energy sources and associated greenhouse gas emissions, effective from the next fiscal year. An organization transitioning its NMS to ISO 50001-2018 must integrate this new legal obligation. Which of the following actions is the most critical first step in ensuring the NMS effectively addresses this evolving legal landscape? Option A. Conduct a comprehensive review of all existing energy performance indicators to determine if they are still relevant under the new regulatory framework. Option B. Immediately procure new energy monitoring hardware to capture the specific data points mandated by the Environmental Agency's decree. Option C. Establish a new subprocess within the NMS for systematically identifying, documenting, and evaluating the implications of the new reporting decree on energy performance objectives and operational procedures. Option D. Update the organization's energy policy to explicitly mention the commitment to complying with the new environmental reporting requirements. The correct answer is C. Establish a new subprocess within the NMS for systematically identifying, documenting, and evaluating the implications of the new reporting decree on energy performance objectives and operational procedures. Explanation: the transition to ISO 50001-2018 requires organizations to update their energy management system, NMS, to align with the revised requirements. Clause 4. 2. Understanding the needs and expectations of interested parties. And Clause 6. 1. 3. Legal and other requirements are particularly relevant when legal frameworks change. Specifically, if a new national regulation mandates the reporting of specific energy consumption data for industrial facilities, the organization must identify this as an applicable legal requirement. This identification process involves understanding the scope and implications of the new law. Subsequently, the NMS must be updated to ensure compliance. This update would typically involve modifying procedures for data collection, analysis, and reporting to meet the new regulatory demands. The organization needs to establish or adapt existing processes to gather the required energy consumption data, verify its accuracy, and submit it in the prescribed format and timeframe. Furthermore, Clause 9. 1. 2. Evaluation of compliance mandates that the organization periodically evaluates its compliance with applicable legal requirements. Therefore, the NMS must incorporate a mechanism to track and confirm adherence to the new reporting regulation. This ensures the NMS remains effective and compliant with external legal obligations, a core principle of ISO 50001-2018. Question 28. A global logistics company, Swift Ship Logistics, operates a vast network of distribution centers, trucking fleets, and administrative offices across multiple continents. They are implementing an ISO 50001-2018 compliant NMS. During the initial planning phase, they identify that their primary energy consumption occurs at their large distribution hubs, particularly in refrigeration systems and automated sorting machinery. Their trucking fleet also represents a significant energy use through fuel consumption. However, their smaller administrative offices in various cities have relatively low and dispersed energy usage, primarily for lighting and HVAC, and are managed by different local lease agreements with limited direct control over energy infrastructure. Considering the requirements of ISO 50001-2018 for determining the NMS scope, which approach would best align with the standard's intent for Swift Ship Logistics to establish an effective and auditable NMS? Option A. Define the NMS scope to encompass all distribution centers and the trucking fleet, while excluding the smaller administrative offices due to their dispersed management and lower individual energy impact, provided these exclusions are justified and documented based on the organization's ability to control and improve energy performance across the included areas. Option B. Focus the NMS scope on the trucking fleet's fuel consumption only, as it is a readily quantifiable energy use across the entire organization, and exclude all fixed facilities like distribution centers and administrative offices due to the complexity of managing diverse energy sources. Option C. Include all operational aspects of Swift ship logistics, including every single administrative office, regardless of size or local management control, to ensure the broadest possible coverage and demonstrate maximum commitment to energy management. Option D. Limit the NMS scope solely to the distribution centers, as they represent the highest concentration of energy consumption, and exclude the trucking fleet and all administrative offices to simplify implementation and reduce initial effort. The correct answer is A. Define the NMS scope to encompass all distribution centers and the trucking fleet, while excluding the smaller administrative offices due to their dispersed management and lower individual energy impact, provided these exclusions are justified and documented based on the organization's ability to control and improve energy performance across the included areas. Explanation: the scope of an energy management system, NMS, under ISO 50001/2018 defines the boundaries and applicability of the system within an organization. Clause 4.3. Determining the scope requires the organization to determine the boundaries and applicability of the NMS to establish the scope. This determination must consider external and internal issues relevant to the organization's purpose and its strategic direction that affect its ability to achieve the intended outcomes of the NMS. It also requires consideration of the energy-related aspects of the organization's activities, products, and services, as well as the requirements of interested parties. Furthermore, the scope must encompass all significant energy uses, SU, identified through the energy review process, Clause 6. 1. 2. The scope should be documented and maintained as information. When an organization chooses to exclude certain activities, sites, or facilities from its NMS scope, it must justify these exclusions based on technical feasibility, economic viability, or operational control, and these exclusions cannot invalidate the organization's ability to achieve its intended NMS objectives and improve its energy performance. The scope should be comprehensive enough to cover the organization's significant energy uses and opportunities for improvement. For instance, if a manufacturing plant has multiple production lines and administrative buildings, the scope must define which of these are included and why. If a specific production line with negligible energy consumption is excluded, this exclusion must be justifiable and documented. The scope should also align with the organization's overall business strategy and its commitment to energy performance improvement. Question 29. Consider a multinational automotive parts manufacturer with facilities across the European Union, recently initiating its transition to ISO 50001/2018. The company is subject to the EU ETS, which mandates emissions allowances and potential financial penalties for exceeding allocated carbon footprints. Which of the following best encapsulates the crucial considerations for establishing the organizational context as per ISO 50001/2018, specifically addressing the interplay between internal capabilities and external regulatory pressures that will shape its energy management strategy? Option A. Analyzing global energy market trends and forecasting future energy prices without considering the specific impact of the EU ETS on the company's operational costs. Option B. Documenting all existing energy consumption data from the previous fiscal year and conducting a preliminary risk assessment for potential equipment failures. Option C. Developing a new corporate social responsibility report and training all personnel on basic energy conservation techniques without linking them to strategic objectives. Option D. Identifying EU ETS compliance obligations, assessing the energy efficiency of its aging robotic assembly lines, and understanding shareholder expectations for cost reduction through energy savings. Correct answer is D. Identifying EU ETS compliance obligations, assessing the energy efficiency of its aging robotic assembly lines, and understanding shareholder expectations for cost reduction through energy savings. Explanation: the transition to ISO 50001-2018 requires an organization to understand its context, which involves identifying external and internal issues relevant to its purpose and strategic direction, and which affect its ability to achieve the intended outcomes of its energy management system. This includes understanding the needs and expectations of interested parties concerning energy performance, energy use, and energy consumption. For a manufacturing firm operating under the European Union's Emissions Trading System, EU ETS, relevant external issues would include regulatory requirements like emissions caps, carbon pricing mechanisms, and potential penalties for non-compliance, all of which directly impact energy strategy and operational costs. Internal issues might involve the age and efficiency of production machinery, employee awareness of energy-saving practices, and the company's financial capacity for energy efficiency investments. The needs and expectations of interested parties could encompass shareholders demanding improved profitability through reduced energy expenditure, employees seeking a sustainable work environment, and regulatory bodies enforcing compliance. Therefore, a comprehensive understanding of the organizational context must integrate these elements to effectively establish the scope and objectives of the energy management system, ensuring alignment with both strategic goals and the specific regulatory landscape. Question 30. During an internal audit of an organization transitioning to ISO 50001-2018, a discrepancy is noted in the energy planning documentation. The organization has established energy objectives and action plans, but the link between these objectives, the identified significant energy uses, and the established energy performance indicators, NPI, appears weak. Specifically, the chosen NPIs do not directly reflect the primary drivers of energy consumption within the most significant energy uses as identified in the Energy Review. Which of the following planning elements, as stipulated by ISO 50001-2018, is most critically underdeveloped in this scenario, hindering effective energy performance improvement? Option A. The framework for ensuring competence and awareness of personnel involved in energy management activities, including those responsible for data collection. Option B. The detailed procedures for conducting management reviews, ensuring energy performance data is presented in a format suitable for decision-making. Option C. The process for identifying and assessing energy legal requirements and other requirements relevant to energy performance. Option D. The methodology for establishing and updating energy baselines and their correlation with selected energy performance indicators for significant energy uses. The correct answer is D. The methodology for establishing and updating energy baselines and their correlation with selected energy performance indicators for significant energy uses. Explanation: the ISO 50001-2018 standard introduced more explicit requirements for planning, particularly concerning the integration of energy performance indicators, NPI, and baseline establishment. Clause 6. 2. 1. Energy objectives and planning to achieve them mandates that an organization shall establish energy objectives and plan to achieve them, taking into account the energy policy, significant energy uses, and energy performance indicators. Furthermore, Clause 6. 2. 2. Energy planning requires the organization to develop and maintain a plan or plans for achieving its energy objectives. This plan should detail how the organization will improve energy performance, including the establishment of baselines and NPIs, and the methods for monitoring and measuring them. The transition from ISO 50001-2011 to ISO 50001-2018 emphasized a more proactive and integrated approach to energy planning, ensuring that objectives are linked directly to the identified significant energy uses and supported by robust baselines and measurable NPIs. This ensures that progress towards energy performance improvement is quantifiable and verifiable. The standard also requires consideration of relevant legal and other requirements, which influences the scope and nature of the energy planning process.